Here we have a question in trigonometry. Okay, let's go over the question. If A and B are acute angles, sine A is equal to 3 over 5, cosine B is equal to 12 over 13. Find cosine A positive B. Here we have three information in the question. The first one is A and B are acute angles. The second one is the value of sine A is given, that is 3 over 5. The third one is the value of cosine B is given, that is 12 over 13. Using this information, we have to find the value of cosine of A positive B. So here, in this question of A positive B, we have the two angle measures are added. That is, we have the sum of the two angle measures A and B. Since we have the sum of the two angle measures A and B over here, we can use the sum identity of cosine in trigonometry. That is, cosine of A positive B equals to cosine A times cosine B. So here we have positive. In sum identity, whenever we have positive sign over here for cosine, so here we have to take negative. Then we have to write sine A times sine B. Okay, this is the identity we have for cosine of A positive B. So here I have to plug in the values for cosine A, cosine B, sine B, and simplify to evaluate the value of cosine of A positive B. Okay, I know the value of cosine B that is given in the question, that is 12 over 13. The value of sine A is also given in the question, 3 over 5. I need to find the value of cosine A and sine B so that I'll be able to evaluate the value of cosine of A positive B. Okay, to evaluate the value of cosine of A positive B, I'm going to use a Pythagorean identity in trigonometry. That is sine square A positive cosine square A equals to 1. So we are all aware of this Pythagorean identity in trigonometry. That is sine square A positive cosine square A equals to 1. Okay, here I have to plug in 3 over 5 for sine A and I have to solve for cosine A in this identity. So we have sine A is equal to 3 over 5. To get the value of sine square A, we have to square this, square the value of sine A. That is 3 over 5 whole square positive cosine square A equals to 1. So the square has to be distributed to the numerator 3 and denominator 5. So then 3 square over 5 square, which will become 9 over 25. Positive cosine square equal to 1. Okay, my aim is to solve for cosine A. So I have to isolate cosine A. That is, I have to get rid of all the values around the cosine A. So first, let's try to get rid of this 9 over 25. For that, I subtract 9 over 25 from both sides. When I do so, the positive 9 over 25, negative 9 over 25 will cancel out. I'm getting cosine square A is equal to 1 negative 9 over 25. Okay, to simplify this one, I need to multiply this integer 1 by this denominator. That is, whenever I add or subtract an integer or a fraction, integer and a fraction, I need to multiply the integer part by the denominator of the fraction. Once I'm done with the multiplication, I have to take this 25 as a common denominator. So 1 times 25 is 25. So cosine square A equals to, multiply this 1 on 25. 1 times 25 is 25, negative 9. So now we have to take this 25 as a common denominator. So cosine square A equals to 25 negative 9 will be 16 over 25. So now we have simplified this one. Okay, now let's try to get rid of this square. So to get rid of the square, I have to take square root on both sides. When I take square root on both sides, the square root and square will cancel out. I just get cosine A on the left side. On the right side, whenever I take square root for a number, in front of the square root, I have to take positive or negative sign. So we know that the square root of 16 is just 4 and square root of 25 is just 5. So we get two values for cosine A. That is, cosine A is equal to 4 over 5 and cosine A is equal to negative 4 over 5. Okay, the question clearly says that the two angle measures A and B are acute angles. A and B are acute angles means both the angles we have in the first quadrant, both A and B in the first quadrant. In the first quadrant, all trigonometric ratios are positive. So cosine A also is positive in the first quadrant. So the value of cosine A, since the value of cosine A is positive, we can ignore the negative value, that is negative 4 over 5. So finally, we conclude the value of cosine A is just 4 over 5. So because we have to consider only the positive value. The reason is A and B are acute angles. And so we have first quadrant. In first quadrant, all trigonometric ratios are positive. So this cosine A must also be positive. So we consider only the positive value. Okay, now I got the value of cosine either is 4 or 5, and I have the value of cosine B in the question. I have the value of sine A, that is also in the question, but still I have to get the value of sine B. Again, I have to use the same Pythagorean identity and solve for this sine B. Okay, let's do this one on the next page. Okay, here let's write the Pythagorean identity for angle measure B, that is sine square B positive, cosine square B equal to 1. Okay, now our target is to find the value of sine B. For that, we have to plug in the value for cosine B, that is 12 over 13 is the value for cosine B, that we have to plug in for cosine B into this identity. So we can keep sine square B as it is. The value of cosine B is 12 over 13. Since we have square for cosine, we have to square 12 over 13. So sine square B positive. When I square this 12 over 13, 12 square over 13 square, which is 144 over 169 equals to 1. Okay, to isolate sine B, I have to get rid of all the values around sine B. So for that, I have to subtract 144 over 169 on both sides, so that I'll be able to get rid of this value. I subtract 144 by 144 over 169 on both sides. So this one will cancel out. I get sine square B equals to 1 negative 144 over 169. Okay, to simplify this one, as I told you earlier, we have to multiply this integer 1 by this 169. Then we have to take this 169 as a common denominator. So sine square B equals to 169 negative 144 over 169. So when we subtract 144 from 169, it will be 25 over 169. Okay, now to get rid of the square, I have to take square root on both sides. So the square root will cancel out. So here in front of square root, we have positive or negative sign. So we have sine B equals to positive or negative. Square root of 25 is just 5, and square root of 169 is just 13. So we get two values for sine B. One is positive 5 over 13. The other one is negative 5 over 13. So the same thing we have discussed in the previous page. So that is A and B are acute angles. So both the angles are in the first quadrant. So all trigonometric ratios are positive in the first quadrant. So the value of sine B also must be positive. So we can ignore this negative value. Okay, now I got the value of sine B, which is 5 over 13. That we can plug in into the sum identity of cosine A positive B. Okay, so let's plug in the values what we have found so far. So cosine of A positive B equals to, so the value of cosine A is 4 over 5 we got over here. And the value of cosine B is given in the question itself, that is 12 over 13. Negative, the value of sine A is 3 over 5. And the value of sine B, we got it here, that is 5 over 13. Okay, so now let's multiply these two fractions. So multiply the numerators and denominators. 4 times 12 is 48. 5 times 13 is 65. Here 3 times 5 is 15. 5 times 13 is 65. So now two fractions are in subtraction with the same denominator. We can take the common denominator 65 and subtract the numerators 48 negative 15. So when I subtract 15 from 48, I'll be getting 33 over 65. Okay, now I got the value of cosine of A positive B, that is 33 over 65.